really well in chapter 6 know what formulas are in the formula sheet. They maybe don't have them memorized, but they know what formulas are in the formula sheet. It's this whole side over here. This here's chapter 5. These last two. It's all of this. Okay? So it's people who know what's on there and how they can move it around. So if I look at sine squared x plus cos squared x equals 1, that's just if something is on the unit circle. Remember, we talked about the unit circle formula where it's x squared plus y squared equals 1, and I showed you why, because the center of the circle is at 0, 0, and that's the h and k, so it doesn't affect it, right? And then it's the radius squared, which is 1 squared. So that's how we got that x squared plus y squared equals 1. Now, if we replace some of these, the sine squared was 1 over cos squared, or cosecant squared, or cos squared was 1 over secant squared, and we rearrange them, we'll actually get these other two Pythagorean theorem ones out of it. Okay? Now, what we need to know is a formula completely like stuck like that and you can never move it around? Is that how formulas work? No. Somehow you guys think that's how these trig ones work, though. Formulas can move, right? They can move around, left to right, right to left, anything can move. We agree? So we're going to look at these Pythagorean theorems and how we could move them. So if I ever had a sine squared x plus cos squared x on my paper, I could literally just take that off, throw it away, and replace it with a 1. Could I not? Because sine squared x plus cos squared x equals 1. So if I had a sine squared x and a cos squared x on my paper, I could just be like, no, thank you. And I could replace them with the number 1, and it would actually be true, because sine squared x plus cos squared x equals 1. Now, I can move these around, so I could say, okay, what if I just had a sine squared x? Well, I could replace sine squared x with what?
1 minus cos squared x.
1 minus cos squared x. So write your formulas below the other one. So if I had a sine squared x, I could replace it with 1 minus cos squared x. What if I had a cos squared x? What could I replace it with? If I had a cos squared x, I could replace it with what? 1 minus sine squared x. And that's how I could rearrange that formula, right, to use them. Now, we're not always just rearranging formulas and solving for a missing variable. That's not what Chapter 6 is. Chapter 6 is we're replacing things in equations so that we can actually solve the equation. Maybe there's a cos squared there and we need it to be a sine squared. Or we're proving. So we're replacing something on the left and something on the right to get them to match. So we do left side equals right side. Or verifying. And we're doing that. We're replacing different things. So we have to know our formulas on our formula sheet because we're literally replacing like a cos squared with a 1 minus sine squared, not numbers. Okay? What about 1 plus tan squared? Well, I could get tan squared by itself. Tan squared x would equal secant squared x minus 1. Or I could say 1 equals secant squared x minus tan squared x. It's just rearranging the formula around. It's a teammate right there. All right. So we have 1 plus cotan squared x equals cosecant squared x, right? So we can do 1 by itself. So we could go 1 equals cosecant squared x minus cotan squared x. Or we could go cotan by itself. So we could go cotan squared x equals cosecant squared x minus 1. It's just rearranging those formulas, right? But those are the Pythagorean theorem formulas that can move around. Now we have these double angle identity formulas. These are the like 3/4 way down on your formula sheet. Now they're double angle identities. So if I had like sine 2, if x was 30, let's say, let's just do one on the side. So if I did sine 2 and I made x equal 30 degrees, let's pretend, okay? I would go 2 times 30 degrees, and then it would equal, this is verifying, 2 sine 30 degrees, cos 30 degrees, right? And by verifying, my next step would be to actually do math. What's 2 times 30 degrees? Just the same as, oopsies, 60? Yeah. So this is the same as 60 degrees. Well, what is sine at 60 degrees? 3 over 2. And then it has to equal that side if this is true. So it's 2 over 1 times sine of 30, which is a half. Cos of 30, root 3 over 2. What do these do? They just become a 1, right? So it's root 3 over 2 equals root 3 over 2. So it's just a formula that works. So if I take sine of 60, it's going to equal 2 times sine of 30 cos of 30. And it's sine of 2 times 30. So it's that double angle identity. Does that make sense, how these are kind of working? And so sine is usually people's happy place because sine only gives you one formula. So when you see a sine 2x, you have to replace it with 2 sine x cos x. You don't have a choice. There's only one formula. Cos 2x gives you 3. So you have to actually make an executive decision correctly on what's better to replace. Okay? So these are all your different formulas that we can use. There's also the addition and subtraction ones, but we're going to do those later. All right, flipping over. So this is actually lesson 6.4 in your textbook. It is the last lesson in chapter 6. Why for art thou would I do it first? Because it uses yesterday's material and because it's fun. Yes, obviously. It uses yesterday's solving. So what am I doing? I'm solidifying yesterday's solving, which will be on your test on Thursday. Correct? So if we can do these harder ones, we can do the solving ones easier. So if I look here, it says solve each equation algebraically over the domain 0 is less than or equal to x is less than or equal to 2 pi. So 2 pi is not inclusive, 0 is inclusive, has to be in radians. Now, what is my problem here? I have cos squared, I have sine, I have a number, right? So could I move everything to the left? Sure. I could go negative cos squared x, subtract the 3 sine x, and then I have a plus 1, and then I would add my 2 over, and I would get it equal to 0, because that's what I do when I have a squared, minus cos squared x, minus 3 sine x, plus 3. And then people are like, I don't know. When you guys do this question, you're like, oh, that's a sine squared, and you replace it, and then you like solve it like factoring. Can we do that? Let's think about it. If cos was n and sine was m, let's pretend. Okay, if cos was n and sine was m, I would have this, negative n squared minus 3m plus 3 equals 0. Have you factored anything that looks like that before? N squared and an m? Or has it always had to have been m squared, m, number? Correct? It's always had to be m squared, m, and number. Yes? So I need it to be m squared, m, and number. So what do I need to change? Well, I need to change this. I need to change that cos squared to a what? Sine squared. If I can change that cos squared to a sine squared, then I have sine squareds, and life is good. I can just factor it, correct? So what formula on my formula sheet, or on that front page, can I replace cos squared that will get me sine squared? 1 minus sine squared. So there is that Pythagorean theorem, x sine squared x plus cos squared x equals 1. And I want to replace cos squared x, so I'm going to say cos squared x equals 1 minus sine squared x. So could I do it that way? Could I replace cos squared x with 1 minus sine squared x from the formula sheet? Yeah? Am I replacing a negative cos squared x, or am I replacing only cos? Am I replacing the negative cos squared x, or am I replacing cos squared x? Right now I'm replacing cos squared x. We agree? So I have to replace the cos squared x. So I need to put that in brackets and then do what with the negative sign? Distribute it. We agree? So I'm going to have negative 1 minus sine squared x minus 3 sine x plus 3 equals 0. Now am I going to have all signs like yesterday? So is today just literally one extra step to try and get it to be yesterday? Literally what it is. I have to remember that I'm replacing the cos squared x, though. I'm not replacing negative cos squared x. So I have to put the cos squared x, do you see that, in brackets? Do you see how I did that? Because I'm replacing positive cos squared. Do you see that? Everyone following me? And then I had a negative sign in front of it, so I have to remember to distribute that through. So whenever you sub in, put whatever you're substituting in brackets. So I'm going to get negative 1 plus sine squared x minus 3 sine x plus 3 equals 0. And then I collect my terms, so I get sine squared x minus 3 sine x plus 2 equals 0. And then I'm back to yesterday, right? Let m equal sine x. So let m equal sine x. M squared minus 3m plus 2 equals 0. You factor and solve. So after this point is yesterday. Try it out. I say what times what equals 2, what plus what equals negative 3, negative 2, negative 1. So I get m minus 2, m minus 1. So I get m equals 2 and m equals 1. And m is actually sine x equals 2, sine x equals 1. Now if I actually typed these ones in, because remember I'm looking where they intersect. So if I actually typed these into my calculator, I would get a sine x graph like this. This is 1, this is negative 1. And then I have a line at 2. Are they ever crossing? No. So it's only sines and coses that this happens to. Don't say cosecant, tan, all those, it still works. If it was a 2, if it was like tan x equals 2, you could totally find answers. Okay? It's just cos and sine that max out at 1 and min out at negative 1. Because the cos graph starts here and does this then. Tan graphs do this. Is it going to pass through it at some point? Yeah. And that's a terrible tan graph, but whatever, you get the point. Okay. So this one doesn't work, so we get no solution from this one. And then this one, we want where y is 1, which is here. And our domain is restricted between 0 and 2 pi, so it has to be in radians. So my answer would be pi over 2. So I only actually have one answer for that one. Pardon? Extraneous means I got a solution, it doesn't work. No solution means I cannot get a solution. Sine x equals 2, no matter how I try, I can't get a solution. If I could get a solution and I plugged it back in to the left side and right side didn't match, then it'd be an extraneous solution. If I get a solution, it doesn't work. It's extraneous. It's outside the scope. Okay, here I have 2 cos x plus 1 minus sine squared x equals 3. What am I going to have to replace? The sine squared x. I always replace the squared. What can I replace the single cos with? The only thing if I go to my formula sheet that I can replace a single cos x with is 1 over secant. Does that seem like it is going to make it better? No, that seems really awful, doesn't it? The only thing I can replace is this. Now, I want to show you something. The formula is sine squared x plus cos squared x equals 1. I can just replace the sine squared x with 1 minus cos squared x and remember to distribute the minus 1 through. Or I could do it in such a way that I would actually get it to be negative sine squared x and I could fully replace it. It doesn't matter. I'm going to stick with just getting sine squared because if I have a 2 or something in front, so I don't forget to distribute. So I'm going to get the sine squared x by itself. So sine squared x equals 1 minus cos squared x. So I can take this sine squared off my page, I can hack it across the room, I can take the 1 minus cos squared x and put it in its spot. Correct? Because they're the same thing. Sine squared x equals 1 minus cos squared x. So I can physically take that sine squared off, hack it away, and replace. But I'm replacing sine squared x, so it has to be in brackets. So I get 2 cos x plus 1 minus 1 minus cos squared x equals 3. Do you see how I replaced the blue with the blue? That's all I did. Didn't do anything crazy. Replace the blue with the blue. So this stays the same. 2 cos x plus 1. And then this has to get distributed in. So I get minus 1 plus cos squared x. And then I subtract the 3 over, because I have to get it equal to 0 if I have a squared, right? Then I rearrange it. Squared, single, number. So I'm going to get cos squared x plus 2 cos x plus 1 minus 1 cancels, minus 3, so I get minus 3 equals 0. Now what could I do? What we did yesterday, right? Try it out. I don't have to do decomp because I have a plus 1 in front. So I get m equals negative 3, m equals 1. Negative 3 is the same, m is cos. Cos x equals negative 3. Am I going to get any solutions from that? No, this is my cos x graph. Maxing out at 1. Minning out at negative 1. And then I have a line at negative 3. Are they crossing? No. No solution. And then I have cos x equals 1. Where does x equal 1? Here. What is inclusive? 0. Is 2 pi included? Does 2 pi have an equal sign? No. So it's just 0. My only solution is x equals 0. Yeah? Okay, so what does this mean? This means if I have a squared, like a cos squared, with a sign that's not squared, I have to replace the cos squared with something with a sine squared, right? Like 1 minus sine squared. We agree? Or if I have a sine squared with a cos, I also have to replace the sine squared with 1 minus cos squared to get them to match. You're always replacing the squared, because replacing the single would be like 1 over sine or 1 over secant or 1 over cosecant, and how is that helpful? That's way worse, right? So what happens if we look at this one? I get so many of you calling me over on a test like you've never learned this before, and you call me over and you're like, Mrs. Lepp, is that supposed to be cos squared x? And I'm like, nope. They're like, I'm just going to make it that way. I'm like, okay, but it's not going to work out well for you. Or some of you don't call me over and change it to cos squared x. That's even scarier, okay? Do you have formulas on your formula sheet that look like this as well? Yeah, they're double angle identities. We agree? So you don't just have squared formulas, you have cos 2x formulas. Please don't call me over and ask me if I forgot to make that a superscript or an exponent looking that device. So if I have a cos 2x and I'm asking to solve, or I have a sine 2x and I'm asking you to solve, that is what has to get replaced, just so you know. It's not like, I wonder if the other one does. Once again, I have a cos x by itself. What's the only thing I can replace cos x with? 1 over secant. Is that going to make my life any better? You're just making yourself have a fraction. Trust me, that does not make it better. Okay? So the only option I have is cos 2x. Now, cos 2x has 3 options. Let's look at that. We have cos 2x is cos squared x minus sine squared x. Cos 2x is 2 cos squared x minus 1. Cos 2x is 1 minus 2 sine squared x. Now, there's no like every time I pick this one, but you look at the rest of your equation to decide what would be a better option. So, cool, we're going to leave that cos 2x sit there for a second. This is what's sitting here in the rest of my equation. I have a single cos and a 1, correct? So if I replace cos 2x with cos squared x minus sine squared x, is that going to be helpful? I'm going to have a cos squared, sine squared, and a cos, and a 1. No. If I replace it with 1 minus 2 sine squared x, now I'm going to have a 1 minus 2 sine squared x, a cos, and a 1. Is that going to be helpful? No. So should I maybe pick the one that has a cos squared to go with the cos and the 1? Yes. If you pick these, are you in trouble, like the 1 minus 2 sine squared x? No, you're just making yourself 70 more steps, because now you're going to have to replace this little sine squared x with 1 minus cos squared x. So you're just making yourself use way more formulas. That's all. But you could go that route and you'd still get the same answer. So I'm going to replace it with 2 cos squared x minus 1. So the blue gets replaced with blue. Now I told you when you substitute, you put it in brackets. Did this one technically need brackets? Is there anything sitting in front of the cos 2x? Like a 2 or a negative sign? No. What if so I wouldn't have to have brackets for this one, correct? I can just drop the brackets off, can I not? What if this was a 2 cos 2x though? Then I would have a 2 in front of here, wouldn't I? And I'd have to distribute it through, correct? A 2, because you'd have to replace just the cos 2x. So the 2 would sit in front and it would have to get distributed through. However, there is no 2 there. So I'm going to get rid of those so it doesn't look like it. So we can just drop the bracket off because there's nothing sitting in front of the cos 2x. So we get 2 cos squared x minus cos x minus 1 plus 1 equals 0. Wait a second. The c goes away. Like the a squared b squared c. The c went away. What happens when that happens? Well, we dealt with these yesterday. The only thing I'm teaching you new is literally replacing that off of a formula sheet. That is 6.4. Okay? So try this one out, and then try out B. This one's between 0 and 360. Okay, we're going to look up here for this one, and then you guys can work on the other one if you haven't finished it. So, we replace the cos x's with m's, or whatever letter you want. I prefer not x, especially in this one, because x is the angle. And we take out a GCF when we don't have that c. Remember when we have the a squared plus bx, but we don't have the c? We always are going to GCF every single time, GCF. So check out an m. We're left with m equals 0, and then 2m minus 1, so 2m equals 1, m equals a half. Then I have to remember what m was. Well, m is cos. So I have cos x equals 0, and cos x equals a half. Cos x equals 0 when x equals 0, which is here and here. And then cos x equals a half when x equals a half, which is here and here. Okay, and it's from 0 to 360, not inclusive of 360. So we have 0 degrees, 180 degrees. Whoa, Lepp, why is no one commenting? It's not where x equals 0, that's where y equals 0. Silly me. Right. We're just going to make it a shorter graph. There we go. Cool, fixed it. Okay. Oh. Okay, so it's 90, 270. And then this one is 60 and 300. And then we say x equals 60 degrees, 90 degrees, 270 degrees, 300. And then box it because you're proud of it. Right? You agree? Okay. This one, sine 2x, yeah. Sine 2x. Sine 2x has one option. That's it. Every single time it has one option. It is 2 sine x cos x. Does it have a number in front of it, or is it just sine 2x? Is it negative sine 2x? No, it's just sine 2x. So can I sheerly replace it and not put in brackets when I don't have a number in front or a sign in front? Yes. So sine 2x is the same as 2 sine x cos x. Do you see how just putting this in, I've immediately put in 2 different sines and coses, correct? The moment I replace sine 2x, I have 2 sine x cos x. 99.99999% of the time, your next step is going to be taking out a GCF. Because right now, without even putting anything else on, I have a mixture. I have a sine and a cos together, correct? And I don't have to deal with that. So then I'm going to get minus cos x equals 0. So I told you the next step is possibly taking out a GCF. Now, some people can see that you can take a cosec here and they can work with it. Some people are like, no, thank you. So they go, let m equal sine x and let n equal cosec, and they get rid of both of them. So they go, now why can I deal with this? Because both have a cosec, correct? There's no squareds. The only thing I could replace here is 1 over secant or 1 over cosecant, which once again, not helpful. So I can go 2mn minus n equals 0. What can I take out? An n. Could I have just taken a cosec out and not converted these to any letters? Absolutely. Whatever you're comfortable with. But make sure if you are converting it to letters, you have let statements. You have to have let statements. So I take an n out. I'm left with 2m minus 1 equals 0. I get n equals 0. And I get 2m minus 1 equals 0. So n equals a half. Now the problem here is that some people replace them backwards when they put them back in. Like double, triple check what you're replacing with. So n is cosec. And m is sine x. So where does x equal 0? We just discussed this. Here and here. And now we need where, this is supposed to be, where sine x equals a half, which is here. 30 and 330. True? That's cos. Oh boy. Sine x equals a half here. 30 and 150. This is 90 and 270. It is a sine. Okay, so we get x equals 30, 90, 150, 270. Can I list these out of order, or do I have to list them from lowest to highest?
Lowest to highest.
Can I list them out of order though?
Mm.
Yeah, they're all answers, right? I can list them in whatever order I want to. They'll always list them from low to high or test, but you could go 30, 150, 90, 270, and you'd be completely correct. You could list them all separate in 4 boxes. If you really want.
Make it play Where's Waldo?
But there'd be box.
Could there be boxes to be a little more obvious than Waldo? See, where's Waldo in a box?
How don't you like
Yeah.
Where's Waldo? You find Waldo.
Yeah.
Where's Waldo is my favorite thing ever.
Where's Waldo with a
You
circle?
can't find it.
Okay. Your homework is this.
Jeez, Ty, look what he did.
What did I do?
What did you do?
He gave us homework.
No, he didn't.
Here,